Hello everyone. In this lecture, we will learn about the classification of solids. Before that, let's get familiarized with the term order. What do we mean by order? Order means nothing but there's a definite pattern of arrangement of constituent particles in the crystal. Please note that constituent particles could either be atoms, molecules, or ions. Now, let us see the types of order. There could be two types of order, which are long range order and short range order. Long range order means that the ordered arrangement of constituent particles is present over large distances in the crystal, while short range order means that ordered arrangement of constituent particles is present but only over short distances, as the name suggests. This is an example of a long range order. You can easily see that this structure is highly ordered. Now, in this figure, you can easily see that this is an example of short range order. I have highlighted the portion which are showing the ordered arrangement, and you can see that these are only over short distances. Now, solids are classified on the basis of type of order in the arrangement of their constituent particles as the crystalline solids and amorphous solids. Crystalline solids, of course, they have a long range order. For example, sodium chloride and quartz. Amorphous solids, those having a short range order, are placed under amorphous. Please note that in Greek, amorphous means no form. Here are certain examples of amorphous solids as glass, rubber, plastic, quartz glass, etc. This is a diagram taken from your NCERT textbook representing the crystalline and amorphous structures of quartz and quartz glass respectively. Now let us look at some of the interesting facts. On heating, amorphous solids develop crystallization in them at some temperatures. The second point is glass objects from ancient civilizations, they are found to become slightly milky in appearance because of the presence of crystallization in them. Amorphous solids can flow though very slowly, and hence they are also called pseudo-solids. Pseudo means false solids or supercooled liquids. Example of a supercooled liquid or a pseudo-solid is glass. Glass panes fixed to doors and windows of ancient civilizations, they are slightly thicker at the bottom as compared to the top because over the time glass flowed down, thus making the bottom portion slightly thicker. Please note that glass, of course, it flows but very slowly, and hence it is a supercooled liquid or a pseudo-solid. Anisotropy. When the physical properties, for example, electrical resistance or refractive index, they show different values along different direction in a crystal, the property is called anisotropy. The reason is that there is a different arrangement of constituent particles along different direction in the crystal. Crystalline solids show anisotropy. You can easily understand this by looking at this diagram. Here you can see that along the direction AB, the arrangement of particles is different as compared to the direction CD, thereby representing the property anisotropy. This is the diagram of a crystalline solid. Now, isotropy. When the value of any physical property is found to be same along each direction, the property is termed as isotropy. The reason, you could have guessed it very easily, because the arrangement of particles along different direction is same in this case. Why is it same? Because if you look at any direction, the arrangement is highly disordered. So the value of any physical property would be same in any direction, and we call it isotropy. Amorphous solids, that's right, they are isotropic in nature. Now let us quickly look at the differentiations between the crystalline and amorphous solids on the basis of certain properties. Here is our crystalline solids, now amorphous solids. Now the properties, for example, shape. Crystalline solids have a characteristic and geometrical shape. Amorphous solids are irregular in shape. Coming to the melting point, crystalline solids have a sharp melting point, while amorphous solids soften over a range of temperatures. The next point is cleavage property. When cut with a sharp-edged tool, crystalline solids generate the newly surface, which are plain and smooth, while amorphous solids, when they are cut with a sharp-edged tool, the newly generated surfaces are rough and irregular. Heat of fusion. Crystalline solids have a definite and characteristic heat of fusion, while amorphous solids do not have a definite heat of fusion. Crystalline solids are anisotropic in nature, while amorphous solids are isotropic in nature. Crystalline solids are true solids, as we all know, and amorphous solids are also called pseudo-solids or supercool liquids. Crystalline solids have a long range order, of course, and amorphous solids have a short range order only. That's all for today, guys. Thank you all for joining the lecture.